And on to our last problem. So in this problem we have a solid block, rectangular block of graphite, and that flows at the interface of two immiscible liquids. So let's draw this out, because the best thing you can do when you read a problem is draw it out and visualize it. So this is our system, and we have a rectangular block of graphite within that system, and it's floating at the interface of these two immiscible liquids. And the bottom liquid is oil, and the top liquid is water. And this is carbon. And of the total block volume, 54.2% is immersed in the oil. So this is 54.2%. And since we know that 45.8% is immersed in the water. And in a separate experiment, an empty flask is weighed, and 35.3 cubic centimeters of the lubricating oil is poured into the flask, and then the flask is reweighed. And we know how much the flask weighs, and they want to know how much is the flask going to weigh once that specific volume of oil is added to the glass. So really what we're looking for is we want to figure out the density of oil so that we can figure out how much the oil in the flask is going to weigh, since we do know the volume. Since we know the volume, if we figure out the density, we can very easily get the weight of the oil and the total weight of the flask plus the oil. So let's think about this system. So the buoyant force is going to be equal to the weight of the block so the mass of, another way to think about that is the mass of the liquid that's displaced is equal to the mass of the block. So we're gonna write that out in equation form, and that's going to look like this. So the density of the oil, 0.542 V plus the density of the water, which is 0.458 V, is gonna equal the density of the graphite, and the V in here is the volume of graphite. So we know that 54% of it is taken up by the oil, 45% the water. So that's where those numbers came from. And we're gonna see here that the V cancels out because it's in every term. And then what we're gonna do is go to table B1 in your textbook, which is like appendix area very towards the end of the textbook, and you're going to get density of the graphite and density of water. So we're going to get that density of graphite is equal to 2.26 grams per centimeter cubed. And density of water is going to be 1 gram per centimeter cubed. Didn't really need to look that one up. And what we're going to do now is we're going to plug in and solve for density of the oil. So now we have density of oil, 0.542, and we have that plus 1 gram per centimeter cubed, 0.458 is equal to 2.26 grams per centimeter cubed. And so we're just gonna get from there that, so 2.26 minus 0.458 divided by 0.542. We are going to get that the density of the oil, oh, it's very dense. It is 3.325 grams per centimeter cubed. So this is a very dense oil. You can see it's like 3 times the density of water. It's denser than the graphite itself. It's very dense oil. And now we can move on to solving what we're really looking for, which is we want the mass of the oil. So we know that mass is equal to density times volume, since density is equal to mass over volume. It's just rearranged that way. And we can plug in the density that we just solved for, 3.325 grams per cubic centimeter. And we can plug in the volume that we were given up here, 35.3 centimeters cubed. And we can get 117.4 grams. So we have the mass of the oil, and we were given the mass of the flask up here in the problem statement. So the total mass is just the sum of those two. So 124.8 grams plus 117.4 grams, and we get 242.2 grams at the second weighing.